everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the program manager of the Microsoft Reactor Toronto. I will be sharing session resources with you in the chat, but before we begin, I'd like to quickly review our code of conduct and our event guidelines. First, please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will be sharing the link in the chat for our YouTube channel. And if you've not been on a live stream to YouTube before, please note that you must create an account on YouTube in order to access and interact in the chat. You can set that up now. And if you're unable to use the chat but have questions, feel free to reach out to us through social media. Which brings us to today's session. Let's code a drone using ChatGPT and Azure. I'm going to bring in our speaker here for the day, Bruno. Hi, Bruno.
Hello, everyone. Hey, super happy to be here. Super happy to start to talk about drones and ChatGPT and more. So this is going to be a fast session. First of all, let me show you what we are going to do today. I'm going to switch cameras a lot. This is my drone. I'm going to make the drone fly later here in the back. I have another camera somewhere here to point there. So, hey, help me. Bear with me while I am trying to make everything happen. So go back to the view here, and I see people joining from Miami, from other places. I will take a look on the comments and try to say hi and answer questions kind of in real time. So let's start here. What do we have? What are we going to do? What are we going to talk today? So first of all, the drone that I show, we are going to write from scratch a couple of lines of code with Python to manage the drones. We are going to talk a little about drones, and then we are going to see, okay, we have these kind of things up and running. What else we can do with ChatGPT? How we can use Azure OpenAI services to improve this? And this was working. It's kind of playing with fire. Let's see how it works. Let's see, hope it works. I have also recorded a couple of videos just in case. So that's why, big disclaimer, please don't do this at home. Please, sorry for the bad jokes, the crappy code and everything. So let's start. As I said, I am going to go fast. Initially, we plan to host this session live at the reactor. We have so many people interested that we switched to virtual, and we are going to host the session in a bigger space. So if you want to see this live here in Toronto, we are going to host this live here. So hey, I see Joseph from Vancouver. Hey, hello. So what I am going to use? I am not, if you know about drones and SDK and programming, you probably knows that those drones are expensive. I mean, not expensive, over $1,000 in the big price. The unit there is $1,000. For this one, the one that I'm going to use today is a toy. This one is a very small one. It's called DJI Tello. It's around 100 Canadian dollars, depending on if you find this on, I don't know, on a Black Friday, on some kind of a special offer. You can even get this for $70, something like this. So it's not very expensive. And I like this drone because, again, it's a toy. So you don't expect to have 2 hours battery flight or something like this. You have 10 minutes battery flight, which is kind of nice. It has a good camera. The camera is a 720p, which is kind of nice. It basically has a Wi-Fi. When you connect to the drone is a Wi-Fi hotspot, so you can use there. And hey, you can connect to the drone, and then the drone has a couple of cool features. It basically stabilizes in the air, automatically land when it's run out of battery. A couple of cool things, but what really likes me the first time I saw this drone is that someone shared with me a programming competition, a programming video where I see some kids using Scratch. Scratch is this visual programming tool, and they program the drone. They control the drone, and they make the drone fly, and they make the drone take off and land and do all of these kind of amazing things. And you can take a look here. Scratch, and by the way, I'm going to somehow the vacuum started, so I am going to stop the vacuum there. But you can take a look here. It's a programming mobile programming environment, which is kind of nice. And hey, I like it. It was nice to see an empty bin. There it is. No. Oh, that's a lot of noise. It should be out any second. So it was kind of nice and asked me basically, in my head, I started to think, okay, maybe we have some SDK, we have something here to use with the drone, and I couldn't find anything. Literally, I searched for an official SDK and I couldn't find anything, but I found a PDF deep on internet where basically they explain how you can connect to the drone. When you connect to the drone, you have an IP. Remember, this is a Wi-Fi connection, and you can open a couple of UDP ports to the drone to get information from the drone, to read drone info, to send commands to the drone, and also to access to the camera. And yes, you are using UDP. If you don't know, okay, that's Ace the puppy here in the door. He's going to be here anytime soon. Hey, Ace. So if you don't know, there is my dog is here. So if you don't, okay, he's here, he's happy. If you don't know UDP, it's not the best communication protocol ever. When you're doing TCP, basically you have two parts. The two parts connect each other, make a handshake, and start to share information. In UDP, you send the package and you wish for the best, kind of something like this. I say a lot of people are also here. I'm checking the comments here. So this is what we have. And in the PDF, it also includes some commands that we can use to make the drone take off, move right, move left, do a flip, and more. So with all of this, I decided, okay, I'm going to do something. I'm going to create something, and this is how we get. By the way, I only have one more slide. This is how I explain to you how I have set up everything today. I have my computer connected to the cloud via a network cable, and I am going to connect to the drone using a wireless connection. And I basically share this because you are going to see me doing this a lot today. So I am going to open a command prompt. Let me split this command prompt. There it is. Make this a little bigger. And here I am going to ping the drone. That's the drone. I'm pinging the drone. Ping T. It's going to ping forever. I'm going to turn on the drone. And when I turn on the drone, I am going to be able to connect the drone to my wireless. So if I go here, let me go to Zoom it, and I open my network connections here. Somewhere here, I will see, there it is. This is my drone, and I can connect the drone here directly using Windows. But the problem, if I use this, I connect this using Windows, Windows will detect that the drone is not an internet connection, and it will switch to a better one. So that's why I have another command here, netsh wlan connect, and the drone interface. And basically what I am going to do is, I missed a part here, Wi-Fi 3. I'm going to connect to the drone using a command here. So now I have this, I have the request, and at any moment in the ping, we see here that I am connected. So the ping is going to start to reply, I'm connected. And I show this because, remember, this is a toy. This is not a standard one. So it will show me from time to time, it will show me that it's not connected, it's not working. I'm sorry, is disconnected and more. I am trying to find there it is. I'm stopping the Roomba so we can continue working. So this is my connection stuff. This is what I was planning to show in the connection. And then let's do the hello world. The hello world is basically write a couple of lines of code to connect to the drone, get the battery, and make it fly. So let's do some coding. And as I said, I am going to use Python. I have Python here. Let's create a new file. Let's do this demo.py. There it is. Let's change the layout so you can take a better look. And let's do a little zoom here. Perfect. So first of all, what I am going to do, a couple of imports here. This one is better like this. So I'm going to use sockets, time, and threads. Remember, sockets to open the UDP port and connect to the drone. Time, I'm going to make some routines to manage the timeouts, and threads. We're going to get there soon. So next, I am going to write a receive function. And this is how it's going to work. So this is the first, don't do this at home. I am going to use a while true here, and I am going to have a socket. I'm going to create later, and this is going to be request all the time in the second don't do this at home where I try, except with no catching, without handling exception, but I'm going to receive chunks of 1024 bytes, with basically I'm going to receive the drone information, error and if it's working or not. And then I have another socket here, the state socket, that is the one that is going to give me information from the drone, like in example, the battery level, the altitude, the accelerometer, a couple of more information. So I'm going to receive chunks of 256 bytes here, decode them from Axie, and then start to show this. So in example, I know here that the battery is the item 21. And we are going to see this up and running in a couple of seconds. So I am reading information. So how do I send commands? How do I send something to the drone? So this is it, how we are going to do it. So I am going to have a function, send command in example. The other is kind of overload of the function, sorry. And what I have here is a timestamp with the current time. Then I have the client socket sent to the address that I know. Remember, I know the ping, I know the IP. I am going to encode the command, and the command is take off, move right, move left, flip, do these kind of things. And then I am going to wait 5 seconds here to see if I have a response from the previous one that I am reading, and I am going to return the response. The response is only okay or error. That's everything that I have, and I don't even know what command is associated to the response. Otherwise, I'm going to return false. So this is kind of a way to do this. And as I said, I have a couple of ways here to a couple of I create a couple of variants of the function so we can get better view of this. So I have the info to read from the drone, send commands to the drones. So now it's time to connect to the drone. Oh, sorry. It's time to make the connection to the drone. And what I am going to do here, again, super simple. I know the IP. I know the ports here, 88, 89, 88, 90. And what I am going to open is 2 sockets. And by the way, I love Python. This is so easy in Python. I did the same. I am doing the same demo in C++ and C# a couple of times. And it's easy, but I need to write much more code. Open UDP socket here is just 2 lines of code, and it works amazing. So, hey, this is what I have here. 2 sockets to send info and to receive info from the drone. Open here, and that's basically almost there. The only thing that I need to do next, and this is also kind of nice, is create 2 new threads to basically run this while true forever, to read information from the drone and to read the state, okay or error when I send command. And that's it. 2 new threads with daemon mode enabled, and we can run and we can create our first application, which is read the battery information. Super simple. And by the way, we just write an SDK with 100 lines of code, I will say, and it works. It's amazing. I love it. It's super easy, and is the entry point of everything that we are going to do and see today. So this is the hello world here. The first thing that we need to do is to send this command, a text called command, which basically is going to say to the drone, hey, you are working with a non-official SDK. After that, I am going to read one of the values, the battery. All of this is described in the PDF. And then I am going to do a time sleep, 5 seconds, and wait for the battery value. So let's give this a try. So let's save this. I will go to copy the path. I am disconnected here. Let me open a new one. So let this, and I have here Python 3.7. You can use any Python 3 version, I think. I am going to use OpenCV later, so it also depends on the OpenCV version, but I have here the Python 3.7, and this is the file that I just created, the demo.py. So Python, typo, demo.py, but before, remember, I need to turn on my drone and send the connect command a couple of times until my Wi-Fi connects to the drone. So not yet, one more time. And it should be there. Not yet. So let me turn on the drone one more time. battery should be fully charged, but there it is. So we are connected. Sorry about that. This is the demo one. And we run the demo, go back to demo.py, and I know this is super boring. It's not going to do anything. What I am going to have here is my battery value at 75%. So let's make this a little more interactive. I'm going to go here. I am going to do sleep 20 seconds, and I am going to change a little the code here. So when I read I am going to print the list here, the list of values from the drone. So with this, I'm still connected. Yes, I am going to show the drone so you can see information in real time. And if I start to move the drone around, you can see how the text is kind of scrolling. This is mostly because the drone has an accelerator. The drone has a couple of values. We are going to see the values now, but it has an accelerator internally that basically allows me to see if the drone is moving forward. I have the 3-axis. X, Y, there it is. The 3 X's here are this one, AGX, AGY, and AGC. I also have the temperature here, the low and high. I have the time of flight. I have the battery. I have the vector, the drone. I can't remember how far it goes back, but if the drone is flying in this direction, I can see a vector where basically said how is in the direction that the drone is flying. I always have the 3 axes there for this. I have a barometer information. So, hey, I just connected to the drone and I am sending commands and I am reading info from the drone, which is kind of nice and super easy to do. So the next step, when the first time I did here this one, my next step was, okay, what we can do next? How we can access the camera. So I try a couple of things. I try to access the camera using UDP, using tools like VLC or even the FFmpeg. It didn't work. I tried a lot of stuff. It didn't work. You can see there an example. It has kind of 10-second delay between the real stream and the drone flight. So it was kind of a mess. But then I remember I did a lot of computer vision using OpenCV. And OpenCV is amazing. OpenCV basically allows us to create, let's do drone camera.py, allows us to connect to a drone, to connect to a camera and get the frames of the camera. And we can basically define the camera using an index. If you have more than one camera in your computer, you can go 0, 1, 2, 3, 4, 5, or an HTTP address, or a UDP address, or an RSTSP address. So OpenCV is kind of amazing. So what I am going to do right now is I'm going to use the same general code that I just write. Literally, it's the same, starting with everything here. Main difference here is that I am going to use OpenCV. And then at the end, before doing something on a drone, doing something with the drone, sorry, I need to do something different here. So I'm going to send the first control command, which is command, but then I'm going to send a new command, which is stream on. So basically start streaming. If I don't do the stream on, I am not going to be able to access the camera stream. So once I have this, my next lines of codes are going to be this. I am going to basically say, hey, OpenCV, open a new video capture device, which is going to be in this address. Remember, I know the IP and I know the ports because I have that PDF. And then I am going to be able to use the cap variable, the cap object here to access to the frame. Super easy, super simple. My next step will be show the camera. And this is the app. What I am going to do is I'm going to have, again, don't do this at home, a while true. And in this while true, what I am going to do is, I will use this read command from battery to have a ping. Hans talk about the ChatGPT. Yes, I am going to talk about ChatGPT in 10 minutes or something like this, based on this. But this is the base. I am setting up the context to get there. Bear with me, or watch the recording later and go directly to whenever I start with ChatGPT. But yes, we are going to talk about ChatGPT later. So what I'm going to do here, while true, And in this loop, I am going to access the frame, I'm going to resize the frame, and I am going to show the frame. So I'm going to do here, showing a window that OpenCV has, getting ready for ChatGPT. And then at the end, in this eternal true, if I press the letter Q, I'm going to stop the stream. I'm going to stop the while true. And at the end, I need to do a stream off to basically stop the streaming. Because if I don't do this, I need to take out the battery, wait a couple of seconds, and that's it. So let's give this one a try, because I want to show you. Let's minimize this, go back here again. It's turned off. Sorry about that. Turning it on. There it is. Let's connect. Connect. And when the request said that we are connected, there it is. We are connected. If I go back to my main window, I have the new file here, drone camera. So let's do Python drone camera.py. And now I am going, this is all the bug info from OpenCV. I am going to be connected to the drone, and I will have a window somewhere here. There it is. This is a window that if I start to move the drone around, you can see that this is the drone pointing at me, flying, and you can see there the camera in real time. So by the way, this is all you here. This is what I am seeing right now. And this is me saying hi here. Hey, hello, drone. So super easy. Super simple. Going back here, 150 lines connected to the drone, access the camera, show the camera. Some people, when I do these demos, I have always this question around how fast this is working. So I have here kind of a tweak on the camera lines of code where I'm going to do some FPS. I'm going to show how many frames per second we are working. So let's hope it's still connected and working. This is the same demo, but in the window, in the camera window, we are going to see how fast it is. So if I go here, it says 280, not even close. When you start to move the drone around, it will go down to 30, 40. So we can connect to the drone and work with 30, 40 frames per second, which is super cool, super nice, because this, once we have an image, we can get the next step, which is we can do stuff here. We can use the camera and do computer vision. So we can do face detection. We can detect facial features. We can do face recognition, object recognition. By the way, big disclaimer here. Be very careful about what, if you're planning to do face detection or something like this, which algorithm or SDK or platform you use to do, because there are many, many issues with some standard demos of face detection. But there are amazing things that you can do here. So in example, let me show you. Okay, Peter. So this is what I am. Peter is asking a question here that he says the tail file in it, but can't find the SDK. This is what we were talking right now, that there is no SDK. You can write it from scratch. This is what we are doing today. Later, I'm going to share the resources so you can download this and use it on your own for whatever you want. So let me show you a demo of how we can detect faces. So if we want to do this, and we are on time, yes, in 5 minutes, I want to switch to ChatGPT. So let's do face.py. So literally the same code that we did before, common code, doing everything. Main difference here, is that I am going to use an object that is part of OpenCV that is going to load up a file that have some internal definitions to detect faces. This is a pre-trained model. I would say model. It's not a model. It's a cascade that it will detect faces. So I'm going to create a new object here for face detection. And then what I am going to do, I am going to do exactly the same, while through analyzing showing the image. But before showing the image, what I am going to do, I am convert the image to a grayscale image. Then I'm going to use the face cascade to detect faces. And if I find the face, I am going to show the face in the window. And when I detect the face, I basically have the top right and bottom left points, so I can draw a frame there. And that's basically it. With this, I can show a face. But in order this to make, I need to copy this file, which is the XML with the model here. So let's go here. There it is. Let's show this, and I have face.py. Let's give it a try and then move to. I have here face. There it is, face.py, and I am disconnected. So I'm going to connect again one more time. Show this. I am going to share the code later. Yes, there is a link with the code later. I'm going to show the code later, James, with the demo. So I am connected. Yes, here, there it is. So let's do Python, face.py. It's going to be connected. And this one that I am using today, that's why I say that it's not very good. It's using Viola Jones algorithms, kind of an old one. It kind of works. So if I point the drone somewhere here, it's going to take a while because it's processing. Remember when I start to say that have some issues there. So from there to there, you're probably going to see some frames with the round, with the frame here. So the face was detected, was kind of nice. And hey, it works. If you want to do something better, I have another demo that instead of using this face cascade, use, this is the, let me see the number, the 45. So this one here, this one use a DNN network, which is much more powerful than the cascade, and it detects faces in a much better way. So here, if I point it here and then enable, you can see that I start to move around the, it gets disconnected. Oh, sadly, I pressed the button, I turn it off. This is what's happened, live demos. So sorry, let's run the demo again. Shut down this one. Okay, close the program. There it is. Sorry about that. I hold the drone and got disconnected. Let's connect one more time. But as I said, this is kind of the better way to do this with a much more robust model. But take a look at other algorithms and other services that allows you, if you want to detect faces, or I did several demos, how you can detect screen reads, how you can train your own models, and more to do this. So I have here again the drone here. Let me enable the face detection. And you can see there that, hey, and even can do this like this from different angles, and the face is detected there. So this one works very, very great. And this is the moment that I can start to do more amazing things. So let's take a look at a hello world to make the drone fly. So this is test flight. This is the test flight. Let's minimize this a little, and I have my full set of commands, and this is kind of a first demo that I can do to make the drone flight. I will have this take off, then wait 5 seconds, then I will say, hey, drone, fly right, wait 5 seconds, down 20, it's going to go 20 centimeters, and then land. So this is kind of it's kind of a nice one to test and see these kind of things. But once I know this, I can start to use ChatGPT to help me write this code. And before going there, let's talk a little about how we can use ChatGPT. This is prompt engineer. Basically, this is how we can create specific prompts to be used with ChatGPT. So I am going to use Azure OpenAI. Azure OpenAI is a platform where you can find different models. You can find the GPT-2, GPT-3, GPT 3.5, if you have access also to the GPT-4 models. And what I want to show you is how we can create a specific prompt to help us work with something like this. So I am going to use for this an old model, and I am quoting old. This is DaVinci 2. This is GPT-2. And I have here a very simple question. So I have here a question that is basically said that Janet has a couple of dogs. The dogs give her 16 eggs per day. She eats a couple of dogs for morning and then do muffins and then go and sell the remainder eggs at the farmer market for $2 per each, how much in dollars that she makes every day at the farmer market? So this is a very simple question. Let me prompt this and do this. This is a very simple question. But in this model, in this GPT-2 model, if I ask this question, and by the way, the expected answer is 18. I need to get 18 as an answer. So this model, I set the temperature to 0, which is kind of how creative the model will be, and then the probability is to 1. So in this model, I have a wrong answer. Why? Because the model, the GPT models, these large language models are created to give you an answer, but they don't really understand the problem. GPT-4 will rock this problem, but in GPT-2, this is not a good way to solve this problem. So what I can do to make this a little better, I can go here and replace this question, and before asking my question, basically show the model the path that I can use to solve this question. So basically, I'm going to share a couple of examples. So I'm going to say, first question, there are 3 cars in the parking lot and 2 more cars arrive. How many cars are in the parking lot? And the answer is, there are 3 cars in the parking lot already, 2 more arrive, so we have 3 plus 2 equals 5. The answer is 5. And I'm going to do the same a couple of times. And take a look at this. I will also have these separators here. So I can define here in my parameters that I will use these 3 dots here, 3 lines here, sorry, as stop sequences. So the model will understand that each one of these sections are different parts of this. And at the end, I will have Janet's question. So with this, let's run this demo, let's run this model, and let's see the answer. So here we are. So Janet has 16 minus 3 minus 4 equal 9, cell at 2 each, so the answer is 18. And this is what we expected. This is what we want to have. This is 18. And remember, I didn't change the model. I didn't use a better model, a more advanced one. I didn't switch from GPT-2 to GPT-4. I just changed my prompt to basically explain the model, how the model can solve this using a couple of samples. It's not like this, but think about this. I kind of give samples to the model, so the model now knows how to solve my question. With a similar approach, I can feed my code to the model, to ChatGPT, and from there, I can ask the model to help me do something. So let's give this a try. I have here ChatGPT. Let me go back here. And I can do something like this. Let me go to my model here, ChatGPT, commands 1. So I can use this prompt. And this is the prompt that I have here. I will say, hey, use Python code as reference. Then I will have this code start, and you will see code end at the bottom as kind of standard pieces, standard separators, and standard elements to define where my code starts and where ends. And I will have code here where I have comments and then Python code, comments and Python, comments and Python. And I will show here how to fly the drone left. I don't need the dot right. Move up 5 centimeters, that's fine. Move left, perfect. Rotate the drone and land. So with this, I will have at the end code end, and I am going to ask ChatGPT to generate some code. So generate the code to take off the drone, flip right. I didn't give this one, but it will be smart enough to understand. Move down, I don't know, 30 centimeters and land. So I am going to copy this command and going to paste it here, and let's give it a try. So now ChatGPT is working. Oh, let's do a little zoom there, and let's wait until it's done. So what it's doing here, I like it. Basically, kind of works. So take off, flip right. Remember, I didn't explain how to flip right. It basically ChatGPT assumed that flip L is left, flip right will be flip R. Kind of nice. down 30 centimeters and say the up so it's understand this, and then land, kind of nice. When you work with drones, you know, with this one, we know that we also need to basically remember that we work with UDP, and UDP is kind of tricky. So between each sentence, I need to add some sleep, add some moments so the drone can get the message and then process. So I will say add a sleep of 5 seconds in comments. So it's going to start to generate the code where it is. And hey, this is kind of nice. Take a look at what it's doing here. So first of all, because I am going to use time.sleep, it suggests me to add the import of time. Cool, you know the stuff. And then between each command, I am going to have time sleep 5, which is the one that we want. So let's pick up this code here at the end. And by the way, I love that at the end, it shows that it explains us, ChatGPT, what basically is doing right now. Time sleep 5 command, add a 5-second pause between each command. This can be useful for giving the drone time to complete the previous command before executing the next one. It seems that it's understanding what I want to do, and it's basically saying this will give you some defensive programming to the drone. So I am going to go back to my code here, test flight, and I can't remember. Do I have the battery? Yes. So from battery and down, send control to the drone. So here I'm going to delete this. No, sorry, I need to. From here, I'm going to paste the codes and let's give it a try. So now let's give this a try. Let's make the drone fly. We have time. Yes. Before going to make the drone fly, I need to change a little the layout. So I am going to step. I'm going to enable a second camera. I'm going to enable a second camera so you can take a look at the drone. There it is. And I'm going to make the drone fly in the back. So this is my second camera. Let's turn this on. Okay, and let me open the second camera. There it is. I have it. And I am going to do some magic here where I am going to add my extra camera. High def, perfect. And I am going to try to point this one here so you have a full view of the drone flying there. And I may turn off the LEDs so you can have this. And by the way, this is the camera that we want. Add this one so you can also take a look at me. And I'm going to put the drone somewhere here. Please turn it on. Let me connect to the drone, and this is test flight. So let's connect to the drone. Just in case. Better lighting for the drone, and it's connected. Yeah, so here, Python 04. Oh, sorry. Python 4, there it is. Your camera flying there. And it should fly. Oh, it's hitting my guitar in the back. Okay. And it's going to try to land. It landed on the floor. So hey, kind of nice. Let's tweak a little the code to make something here. So let's go back to ChatGPT and ask ChatGPT to add a flip. After a flip, left after take off. Let's ask ChatGPT to send me the same code, and it's going to do, hey, it's doing very well. So I have the takeoff. I have here my left with the flip. So let me copy this. After the takeoff, the flip left. Somehow it's not flipping, so I need to double check I don't know if I have the right command here. I will save this and let me start it again. So there it is, saving. Let's go and see if we are still connected. No, we are not connected. Sorry about that. Let me connect to the drone one more time. This is the fun part about this. Skynet lead, yes. It's kind of fun. And again, this is just a toy. This is not an official one. This is kind of a fun one. This is kind of a toy, but ChatGPT help us to do this kind of thing. So, let me start this with the drone outside. Otherwise, you will see me flying this one there. So test fly. It should start. Switch the camera. Battery 54. It's not. Okay. It hits the floor somewhere here. That's happened here, but it's not doing the flip. So let's go back to the official documentation and take a look. Why it's not doing the flip? So this is the PDF that describe everything here. So let's shoot down this one. So this is the PDF that I show you that describe this. Architecture, command type, takeoff, up, down, left, right, forward, back, motor, flip, L, flip right, flip forward. So flip should be fine. We are sending flip L, so it should be fine. Yes, battery goes, yes, we are at 50%. Yes, as I said, toy drone, not the official one. I have extra batteries here, but after a couple of tests, you need to get your new there. So let me do this. After the takeoff, I will ask the drone to move forward because my problem, I think it's the tech that is very close to the, so forward, I don't want to hit me, but I will say forward 30. And then do the flip. So after the takeoff, let's do forward 35, sleep, and then do the flip. So let's give this a try one more time. Oh, it's connected, so cool. It should, remember, it should fly up, then move forward. No. Not moving forward. Hey. And then doing a super landing. I'm not really sure why this is not moving forward. It should move forward. I see something here. I need land chain to sanitize and file sale output. Hey, I will give it a try. I didn't know about this one, so happy to give this a try. But this is kind of the idea. So in example, while we do more demos, I have here one demo, which basically is going to do face detection. It's going to do everything that we show, and then it's going to do face detection. And if detect the face, it's going to do a flip. going to do a full flip the drone. So I'm going to start this one. This is the 51, and it's going to be flying, and one is flying and the face is going to do a flip left. And again, I don't know why it's not showing it's not doing the forward. Okay, something happened with the drone. This is kind of the fun one. So 51. So iPhone 51, and we are connected. Yes. So it should start somewhere at any moment here. And yes, I am using here a oh, where is, oh, I changed the location of the models. Where is my model? Sorry. That's face detection, DNN. Face detection, DNN, yes. When I open my models, I move everything here, cleaning there it is. Load face detection model, I know. Let's see if we are still connected. Yes, so 51. And why is not deploy proto.txt? Where is deploy.txt? Oh, and it does get disconnected. Somehow I lost my deploy proto.txt. There it is. So sorry, I am missing something here. Treating CV2, treating CV2, yes, win sound, I don't need sound. And why is not reading the, okay, let me do, just in case, CPU, because I don't have the CPU, and so sorry about that. It should open the network. I mean, this one is working and doing, so let's turn it on one more time. Oh, 34 is an error code. 34 is something. Yes, I don't know what is 34. It's the kind of crappy things that we have with this drone, which is not a professional one. So this is what we have right now. And there it is. So one more time. 111. Sorry about that. I literally tested this before. 111 boxes. Why is not reading the... Okay, crappy solution here. Models. Somehow I lost my deploy proto.txt, and this one somehow it's not reading from the right location, but I should be able to. Okay, mass detector model. I am running 51, yes. Oh, no, I know what I did. Sorry about that. There are 251. Why do I have 251? I don't know. Python 51. There it is, DNN drone flip. Okay, perfect. So let's run this one. So there it is. It's getting there. It will take some time. It's processing the buffer from the drone. Okay, let's wait until it's cleaned the buffer. And in the meantime, while it's working, in this demo, in the 51, I have here a couple of keys. If I press the letter T, it's going to take off. It's going to land with the W, with the L, and then I can move it using the WSAD. So let's give this a try. So let's do not taking off. Okay, demo mode, it's not working. Why it's not taking the letter C? This happens, and that's my dog in the back. Sorry about that. So hey, demo not working. I don't know, something happened. I literally was working 5 minutes before join, and now I get disconnected. Yes, get disconnected. So hey, I hope you enjoyed the time and the demo. This is kind of the idea, and this is how I started to use ChatGPT, basically using natural language to make help with this. So generate the code to take off, flip right, move down, do this, do that. I even have a second demo where I add, hey, write me the frame per second routine to do this, which is kind of nice. And before we are almost at the end, before closing this, sorry, we already talked about demos and prompt engineers. So if you want to get access to these elements, to the demos and to the source code and tutorials, I have everything here in aka.ms El Bruno Drones. You can find the stuff there. I am going to ask Alexia to share this one and on the chat. And also remember that if you are a student and you want to test Azure and have amazing stuff like this one with the GPT models, you can sign for free for Azure for a student, and we have plenty of resources in the Student Hub, which is also aka.ms/learnstudent. Plenty of things that we can do here. So that said, my final ones will be asking you to please, if you have some time, if you have a couple of seconds, this is the link to our survey, aka.ms/reactor/survey. Our event code is 18784, and let us know what you like, what you didn't like, what you want to see in the future. As I said, I plan to do this in person in Toronto in the Microsoft office for a big end audience near time soon. We still don't have the date, but we want to do this big. And this was fun. This was kind of a learning experience. And also here, join our channel in YouTube, follow us on Twitter. We are almost everywhere. So it's a pleasure to be here. I hope that you have a good time. I hope you like it, and see you next one. Goodbye.